Hello everyone. In this tutorial, we are discussing about LSTM. So, what is LSTM? Basically, LSTM defines the long short-term memory that networks a special type of recurrent neural network that can learn long-term dependencies in data. Unlike regular RNNs, LSTMs have a memory set that allows them to remember information for longer periods of time. So this makes them ideal for tasks like language translation, speech recognition, and time series forecasting. So uh, here we take an example of LSTM that is text generation using the RNN part RNN. And at first here in this cell we import our dependencies, and after that we take our basically we open our text file, txt file that is downloaded from Google. We provide you in our video lecture, and we basically open that, and we read that file, and after that we print the file entire file. And this part here we basically find all this thing, this vocabulary. Basically we here we finds all unique characters in the text, and sorts them alphabetically, and after that stores the sorted list in the vocabulary variable. And after that, this character to indices, this line creates a dictionary called character to indices, and loops through each character and its corresponding index I in the vocabulary list, and maps each character to its position. Maps each character C to its position I in the list, and effectively creating a lookup for characters. And the next line indices to character, this line creates another dictionary called indices to character. Similar to the first loop, it maps each index I back to its corresponding character C in the vocabulary list. This allows you to convert numerical indexes back to characters. And again we import our dependencies, that is numpy and pandas. Obviously we need that. And after that we basically subsequence we basically create a subsequence that it defines at first in the first line we define the max length, that is we take here 100. You guys take anything, any number. It defines a max length for each text subsequence. It iterates through the text in steps of the steps using a loop, and within the loop it creates a subsequence of max length and characters from the text and stores them in the sentences. And it also stores the next character, that is text of I plus max length, this thing, and after each subsequence in next characters. So this will be used to predict the next character. And after that, the most important part in text preprocessing technique, that is one hot encoding. So one hot encoding, here it creates two number arrays, that is capital X for input sequences and Y for target characters. So X is a 3D Boolean array with dimensions, length of sequence sentences, max length, and the length of vocabulary, and Y is a 2D Boolean array with dimensions, length of sentences, and length of vocabulary. The loop iterates through each sequence sentence in sentences, and for each character within a sentence, it sets the corresponding element x to 1, and this element represents the character's index in the vocabulary at that time, step t. So in simpler terms, this chunk of code basically defines it basically transform the text subsequences into formal suitable for the model. That is, X represents the character inputs at each time step, Y represents the target characters that the model should predict, and one-hot encoding ensures only the relevant character is active one and each at each position, while others are inactive as zero. And after we building the LSTM network for the task, obviously we need to do that. And basically we create the model architecture here and compilation here. So in this code builds a model that task character sequences as input, process them through the LSTM layer, capture patterns, and predicts the next character probability using softmax activation. The optimizer and loss functions are configured for the training model. And after the after that, we basically uh, yeah after the uh, after that we basically here this function that is the sample index. This function creates an uh, this function takes the basically model's probability prediction and injects some randomness to sample the next character during text generation. And after this chunk of code, this chunk of code basically helps to this chunk of code basically it creates a lambda callback basically, that is object print callback, and assigns an epoch end function to it, and this callback will be triggered after each epoch during training. And this line creates a callback function like this print callback that monitors the model's training by generating the text at the end of each epoch. Here's just simplified explanation. Lambda callback. This creates a callback object during basically object using the lambda callback class. Callbacks are functions that executes at specific points during training. On epoch end, this assigns the on epoch end function to the callback. This function will be called after each epoch, and on epoch end function, and basically it prints messages indicating the start text generation for the current epoch, and generates text with different randomness levels, and prints the generated text for the each level. And after this step, basically this code ensures the only model with the best performance during the training is saved and avoiding unnecessary storage usage. And finally, we train our model. As you can see, it is currently running, and currently running for last 18 minutes. So you have to be you have to be patient, and keep patience, and it will run. So basically I define uh, what we want to do. Basically, we here in chunk of code basically fitting the model and the data. And after this chunk of code, this is the main thing at the and this is called the output chunk, we can call it. So this output chunk, basically this output chunk, uh, I can explain you that line by line, that basically generates the text as we define generate text. So this calls a generate text function that we defined earlier. So it provides two arguments, that is length, this specified desired length number of basically the number of characters for the generated text. In this case, that is 500. And after that, so diversity equal to 0.2 means this sets diversity level the text generation. Lower diversity means the model is more likely to choose the most probable next characters, so resulting is in a smoother but potentially less surprising outcome. And so this print statement displays the generated text returned by the generated text function call, and this allows you to see creative output based on the diversity level. So here we learned that what is LSTM and its application in real life. So yeah, thank you guys.